Hi, this video will break down what happens if there's a price increase of good X, when good X represents a normal good. First, I want to present an overview discussion before we launch into the details of the graph, because this concept typically is a very challenging concept for students to master. However, I think the intuition is rather straightforward. So let's show that intuition. Consider the following case. Again, the price went up for good X, and good X is normal good, which of course, normal good, we know what that means. If as your income rises, you buy more of good X. As income falls, you buy less of good X. So let's hold our income constant. And let's keep the price of the other good Y, constant. So the only thing that's happening is there's a price increase of good X. What will happen to our budget constraint? Of course, graphing Y on the Y-axis, X on the horizontal axis. What happens to the budget constraint if the price of X goes up? The budget constraint, of course, gets a steeper slope. So what do we expect to happen, the total effect, our total consumption of good X, if we have increased the price of X? The total effect should show a reduction in good X. Recall and look at the previous video on overview of decomposing a price change that we discussed both substitution effects and income effects. A substitution effect, what is it? This simply says consumers swap out between good X and good Y, and in this case good Y didn't change in price, but good X did. Good X became more expensive. So what do we expect to happen? We expect consumers to move towards the good that looks like it's a relatively better deal. In this case, good Y looks more attractive since its price didn't change, only the price of X went up. So we would expect a substitution effect to indicate less consumption of X and correspondingly more consumption of good Y. What about this income effect? What is that? Income effect says when prices go down, like in this, and when prices go down, consumers buy more of the good, more of a normal good. In this case, the price of good X went up. So now people feel poorer, so they're going to buy less of good X and less of good Y. So we expect the income effect then to cause us to buy less of X because we feel poorer. We expect the substitution effect to cause us to buy less of good X because now we want to buy good Y since it looks like a relatively better deal. And the total effect adds these two effects up. So we are going to buy less of the good because the total effect reflects that both the substitution effect and income effect are buying less of good X. Let's show this on a graph, the more challenging part. So on this graph, let's first set up the scenario. And the scenario that we have is we are on bundle E1 is the optimal bundle. Why is this the optimal bundle? This is before the price of good X went up. In this case, good X is represented with T, or music tracks, and good Y is indicated with M, live music per quarter. And so here's the budget line for the live music per quarter, and this is the blue, this light blue slope that's relatively flat. The optimal bundle is E1 because that's the tangency of our indifference curve, I2, with the blue initial budget constraint, L1. So there's our best bundle, which involves 24 music tracks, T. Now, what's happened? Well, we've raised the price of X, or in this case, represented by T, or music tracks. We've raised the price of X. So this causes our budget constraint to get steeper. So now we're at this darker blue. And where that darker blue is just tangent to an indifference curve is at bundle E2. This is the new optimal bundle at the higher price of good X. So the total effect then is going to be moving from E1 to E2, or 12 units reduction in the X good, represented by T. Now, to figure out which part of these 12 unit reduction is due to substitution effect and which part is due to income effect, we need to graph another line. And this another line is this hypothetical budget, here represented in yellow. And this hypothetical budget in yellow represents a couple of things. So it meets two criteria, this hypothetical budget line in yellow. It allows us to obtain the original utility level, represented by I2 in this graph, yet it's going to reflect the new price ratio, this steeper budget constraint. So let's go back to our graph. So this yellow curve reflects the steeper budget, yes, because that's the new price ratio. This yellow curve allows us to reach the original indifference level, I2. So you're going to push this yellow curve out to where just tangent to the initial indifference curve I2, and that's this hypothetical bundle E star. So E star is a tangency between the yellow and the original pink indifference curve. And so moving along this indifference curve from E1 to this E star, this is the substitution effect. We're swapping out the X good. We don't want the X good now. We want more of the Y good to obtain the original indifference curve, keeping our utility the same. So substitution effect, moving along the same indifference curve, we now go from E1 to E star. That translates from having 24 units of T to now 16 units of T. This is a reduction of 8 units of T. This is a substitution effect. These 8 fewer units now you want to buy. You're buying more of the Y good, in this case M, and less of the X good. Finally, this was a hypothetical bundle. That's not where you end up. You finally rest at E2 as the final stopping point. So recall that the price of good X went up, you feel poorer. How do we represent that? By shifting our budget constraint in from this yellow hypothetical line to the actual dark blue one, L2. So this is our income effect. We are going to feel poorer. We're going to buy less of the Y good and less of the X good. So going from E star to E2, this is seen as the income effect. And the income effect then is represented by moving from 16 to 12 units of X, or 4 fewer units of X. Add those substitution effect, 8 less X, plus the 4 less X from income effect, gets you your total effect, or a 12 unit reduction in good X due to this price increase. This is an analysis of income and substitution effects and corresponding total effects due to a price increase of a normal good.